Hello, calculus fans! Let's take a look at some derivatives of inverse trig functions. These are going to be pretty important. Now, we've talked about the derivative of inverse sine. So if we want a derivative of inverse sine of x over a, we're going to have to use the chain rule. So the basic version of it, it looks like this, 1 over 1 minus something squared, but then we have to multiply by the derivative of the inside function, and that's how we end up with this piece here. Now I'm going to simplify this a little bit. First, I'm going to take 1 over a and change it into 1 over square root of a squared. I didn't really do anything there. But what I want to do is combine these two denominators by multiplying them together. And then when we do that, we end up with 1 over square root of a squared minus x squared. Let's try inverse tangent now. All right, same deal. Instead of just having inverse tangent of x, I'm going to make it inverse tangent of x over a. All right, so same deal. It's 1 over 1 plus something squared. So the something squared in this case is the x over a. We have to square that whole thing to get this. And then we have to multiply by the derivative of the inside, which is 1 over a, just like before. All right, now I'm going to try to rewrite this. I'm going to change 1 over a into a over a squared. Seems like a funny thing to do, but that's because I want to take this a squared down here and distribute it here. So we end up with a over a squared plus x squared. So what this really tells us is that the derivative of 1 over a, arctangent of x over a, is equal to 1 over a squared plus x squared. Okay, so how did we get that? That's basically saying, well, this is equal to this, so now let's divide both sides by a, and that's how we end up with a formula that looks like this. All right, we've done arcsine, arctangent. Let's talk about arcsecant. So derivative of arcsecant, 1 over, okay, so 1 over that thing times square root of that thing squared minus 1, and then the piece at the end, the 1 over a, that comes from the chain rule. And now again, we're going to try to clean this up. So just like we did before, I rewrite it as a over a squared, the piece on the outside. Now we'll multiply the a squared onto the denominator, and instead of an x over a, now we get xa, because essentially one of these a's will cancel with one of the a's here. Okay, one more rewriting. I'm going to change this a into square root of a squared. That way we can move it onto the inside of this radical. And so here's what we get for our final thing. A over x times square root of x squared minus a squared. Now just like before, I can write down a formula that looks like this. That the derivative of 1 over a arcsecant of x over a is equal to 1 over x times square root of x squared minus a squared. Now this gives us 3 integration formulas which I think are worth memorizing. So when we wrote these down before, we didn't have an a in place, or maybe we could think of it this way, we just had a is equal to 1. But this time, we're going to have an a, so we could have any number there. Now a has to be a number. X is the variable of integration. Let's see, one thing to notice, it's kind of funny, 2 of these formulas have a 1 over a in them. The arcsine doesn't. I think that's just an accident. There isn't any real good reason for that. All right, so essentially, I would like us now to have these 3 anti-differentiation formulas committed to memory. They're going to come up often enough that you will definitely want to have this in your memory banks. Okay, that's all for now.